Assalamualaikum warahmatullahi wabarakatuh. Good day everyone. For this today lecture, we proceed with the method how to control the molecular weight in step growth polymerization. So obviously we can see that there are three ways to limit the molecular weight in step growth polymerization. So why we want to limit the molecular weight in step growth polymerization? Because the certain polymer, it needs the certain molecular weight. For example, we have UPE, epoxy resin, we have nylon 66. So in the making of unsaturated polyester, if we have reached a desired molecular weight, um, we need to stop the polymerization by using a rapid cooling, and it will stop the reaction. Hence, we will get the desired molecular weight and viscosity. Routinely, it is done in the manufacturing of unsaturated polyester. So quench means a rapid cooling. This figure illustrates the reactor type that we use to make a polymerization process. So it is either used in the batch reactor, we have tubular reactor. Okay, so the chapter that will cover about the reactor is in the chapter 3, if I'm not mistaken. The second one, we can use an excess of one monomer for type 2 reaction, which is non-stoichiometric quantities. Let me recall back what is type 2 reaction. So type 2 means that we use a bifunctional monomer that contain one monomer, and in a monomer it contains two functionalities. So we just use the small excess of one monomer that will causes the reaction to come to a halt, and will cause the reaction to stop. When only the end group of the monomer present in excess are left, because these are unable to react with each other, means that when the excess monomer is consumedly used, so there is no reaction can be proceed. So we can control the molecular weight, and routinely done in the manufacture of the epoxy resin, so that we can ensure the epoxide end group are present in the oligomer. The next one, we can use the small amount of monofunctional reactant. As we all know, the monofunctional reactant is an organic compound whose the chemical structure, it possesses a single highly reactive site. So the reaction will make the chain end inactive, and it is routinely done in the manufacture of nylon 66 for fiber manufacture by adding the acetic acid as the monofunctional reactant. We can say that monofunctional reactant is actually the catalyst. Alright, now we proceed with the stoichiometric imbalance. When a non-stoichiometric amount of functional group is used, the relationship between the degree of polymerization and the reaction conversion, P, can be quantified by a modification of the Carruthers equation. Now introduce a factor R representing the stoichiometric imbalance. So R is the stoichiometric imbalance. If the number of A and B functional group present at the beginning of an reaction AA and BB polymerization, we can say that R equal to NA naught over NB naught. I'm not sure, not or how can I read this one, but NA naught is the represent the number of A functional group, and NB is the number of B functional group. Okay, means that the number of functional group in monomer A divided by number of functional group in the monomer B. Bukan. Betul lah, monomer B. Okay, so sama macam P, which is extent of reaction, R also must be less or equal to 1. Okay, P is reaction conversion ataupun kita panggil extent of reaction. So it represents the fraction of A groups that have reacted. Because the reaction of each A group consume one B group, the fraction of B reacted at conversion P is equal to P and A or PR and B. And the number of unreacted group in the initial number of functional group A and initial number of functional group B is then given by P is equal to Na minus Na naught minus Na over Na naught. So Na tu apa? Na yang ni. Adalah number of reacted functional group A. So you must be wondering how can we get Na1 minus P Na naught? Okay, so just recall back our previous lecture, which is P equal to Na naught over Na naught minus Na naught. So we can get Na over Na naught 1 minus P. Okay. Same goes to NB, which is kita tambah R je dekat sini. Which is R is for stoichiometric imbalance. Okay. Because we need to put the R at the end of the at the end sebelah dengan extent of reaction. And 1 minus PR is Na naught over R. Next, at this point, the number of A and B functional group is equal to Na plus Nb, and because there are two N groups per molecule, the number of molecular chain N is given by N equal to half Na plus Nb, and so on lah. So equation ni abang tak perlu hafal pun, and tak payahlah nak faham sangat-sangat kan, just for general knowledge. Okay. So the most important equation is dp. We get dp equal to 1 minus p if r equal to 1. This is the final equation, represent the characters equation. And when monomer is completely used up in the polymerization, that is when p equal to 1, which is 100%, the equation become dp equal to 1 plus r divided by 1 minus r. Okay, dua ni equation yang penting. So daripada previous equation, dia tunjukkan macam mana kita dapat dua equation tersebut. If monofunctional reagent is added, which is the catalyst such as acetic acid, to control the molecular weight, according to the definition of R, this must be necessarily be B groups. Okay, kita akan letak R ni dekat functional group B ataupun monomer B. So the imbalance factor is then redefined as Na naught over Nb naught plus 2Nb naught. And Nb naught is number of monofunctional B groups. Okay, kita kena tambah dengan Nb prime naught. Okay, sorry, ada prime kat sini. And factor 2, each B prime molecule is equally as effective as one excess BB monomer in limiting the molecular weight. And factor R prime is substitute for R in the previous equation. Okay, this exercise, can you do it? The question is, what is the maximum degree of polymerization for the reaction of 0.04 mole of the monomer ethylene glycol and 0.05 mole molarity of the monomer terephthalic acid are used, given that the equation of Xn equal to 1 plus R minus 1 divided by 1 minus R. Okay, so you can use this equation to calculate this equation. Okay, so we will discuss the answer in the class. Before you proceed with this equation, you need to use the equation of R. Okay, R imbalance equation to R equal to Na naught over Nb. and then you substitute the number of R in the initial number of functional group A divided by initial number of functional group B, and then you will get the R value, and you substitute the R value in this equation. Proceed with the molecular weight in step growth polymerization. Okay, so polymer molecular weight in a step growth polymerization is determined by the fractional conversion, which is P, which is extent of reaction or conversion during the polymerization. So one way to express the molecular weight is through the degree of polymerization, which normally represents the number of repeating units in the polymer chain. Since any polymerization mechanism yields a distribution of molecular weights, it is necessary to define an average degree of polymerization in the same way as average molecular weight was defined. So, we design as X or dP. dP dengan X ni is degree of polymerization. And the most important average of the number average Xn and the weight average XW degree of polymerization. So you need to know some terms in molecular weight. For example, Xn Xn is the um, number average degree of polymerization. Okay, ataupun nama lain dia adalah degree of polymerization kan. Kalau X number average macam ni. Kalau X average degree of polymerization. Kalau Xn dia ada straight line kat atas ni, kita panggil dia number average degree of polymerization. Kalau XW weight average degree of polymerization. Kalau Mn, M besar N. Kalau Mn, sekejap ya. Ni kalau Mn. Okay, kalau Mn, it is the number average molecular weight. M naught is the average molecular weight of monomer in repeat units. Alright. So, kita tengok balik. Habis ke? Okay. Using MWD, using the statistical method derived by Florey, it is possible to relate the molecular weight to the reaction conversion P. In any polymerization involve a difunctional monomer, which is AB plus AB. Ada dua monomer. So each step reaction links two molecules together. So number of monomer units in the polymer is more than number of functional group reaction. So if a polymer contains X monomer units, which is dP equal to X, so the number of A or B functional group that have reacted equal to X minus 1, and the remaining unreacted A or B groups are at the end of the chain. So kita consider macam ni saja, X minus 1 lah. So you don't need to terlalu nak obsess kenapa macam ni. Okay, memang the scientist dah create dia macam ni. So X ni apa? X is dP. And dP for the step growth polymer when add monofunctional reactor in the mixture. Okay, and the equation will be 1 plus R divided by 1 plus R minus 2RP. And the R is the ratio Na over Nb plus 2 Nm. What is Nm? Nm is the number of mole for monofunctional group. So, we proceed with the dP for step growth polymer when use non-stoichiometric quantities of monomer type 2. And the degree is affected not only by the yield but also the molar ratio of the reacting functional group A and B for type 2. Because type 2 we use only one monomer and that contain two functionality. So if the quantity number of mole for monomer functional group A and B is not stoichiometric, the dP can express by 1 plus R over 1 plus R minus 2RP. Okay, all this equation, if you become a scientist, you will use this equation.